Hi everybody. Today we're going to be using some of the trig functions we talked about on our unit circle day. So we're going to be looking at all three of them today: tangent, sine, and cosine, and finally actually using for triangles. So, uh, first thing to look at, we started a trig table toolkit. So that was one simple way of finding ratios that show up sometimes. It's a quick little trick, but it's not perfect and it's not going to work for every angle. We're not always going to find a nice clean ratio. So we're going to use SOHCAHTOA to actually find specific values. Um, First little exploration is the Leaning Tower of Pisa. It's expected to collapse once its angle of slant is less than 83 degrees. So right now we have some measurements. It's 50 meters above the ground, that little point where we're apparently going to drop a weight from point A there. Um, if we drop something, it'll land 5 meters away, and we can assume that's a right angle because it's dropping straight down towards the ground. So, what's the slope ratio for the tower? Well, if we use the angle of slant that the picture is pointing to, we would do rise over run. 50 over 5 would be a slope angle of 10. Is it in immediate danger of collapse? It should not be. The angle should be greater than 84 degrees. On our quick little trig toolkit, 84 degrees had a smaller ratio than this. So if it's a bigger ratio, it must be bigger than 84 degrees. So since it's not supposed to fall until it's less than 83, we should be safe for now. Next page. So this one, we're going to use our trig table for reference. So looking at the first triangle, we see 79 degrees. 79 degrees is similar to 11 degrees. One of them is a 1 over 5, one's a 5 over 1. Basically, W should be a fifth of 12. So here's some of the work. And here's my brief explanations. 79 degrees has a ratio of 5 over 1. W must be about 2.4. 22 degrees has a ratio of 2 over 5. Z must be about 3.2. So again, we'd be multiplying 8 by 2/5 or 0.4. And then letter C, 18 degrees has a ratio of 1/3. 1/3 of 5 is or 1/3 of 15 is about 5. All right, so that's just using our trig tables, and these are estimations. These are some of the nice ones we found. But what if we want to use other angles besides these ones that are just on our piece of paper? All right, so multiple methods. We have Tiana, Maylin, Eddie, and Amy looking at a triangle. So if we rotate the triangle so it looks like a slope triangle, we would have change in y over change in x. Change in y would be 4. Is that going to work? It should, because we have a 1/3 ratio for 18 degrees. So we could figure out that a would be about 12, since 4 is a third of it. Then we have Maylin. I see it differently. I can tell delta y equals 4 without turning the triangle. Well, yeah. Something else we could look at is the right angle symbol between A and 4 would be another sign that that's where our slope triangle is going to be. But what if we use 72 degrees, says Eddie? Then we would be using the reciprocal. So it would be turned and steeper. All right, so we'd have A as the tall side, the change in y, and then the change in x would be the 4. So if we use Eddie's observation, 18 degrees, the reciprocal would be 72 degrees, 3 over 1. We would still get 12 for A. Changing the orientation shouldn't change our answer for that. The next page, finally, using our trig functions, if we look at this triangle, we have a 32 degrees angle. What would the slope ratio be? If we do rise over run, we should get 5 over 8, which is the decimal 0.625. The 58 degree angle is just the other one. It should be the reciprocal, which is 8 over 5, or about 1.6. So then reading letter C, if you have a calculator, you would be able to use trig functions with 32 degrees. So tangent of 32 should give us the 5 over 8. Tangent of 58 should give us the 8 over 5. And so what you're going to want to do, just to test out and make sure you're in degrees, is actually type in tangent 32 and tangent 58. If you don't get answers near the decimals we're getting, you need to make sure your calculator's in the degrees setting and not the radians setting. Radians is a different measurement. It's still an angle, but it's going to be different numbers, so it's going to mess up what we're trying to do today. All right, moving on. So we have a few more triangles. This is a team try it. So I'm just going to put the answers on the screen. This would be a good time to stop, do the problems, check in with the people around you. Here are the answers. So check your answers. If you got any of them wrong, go back to them, see if anyone else got them. Use each other as a resource. This is an opportunity to try it yourself without me talking through the entire thing. So you should be using tangent for each of these since we don't know the hypotenuses yet. Cool. Next, we're going to look at situations where we're missing one of the change in y or change in x. This means we're not going to be able to use tangent anymore. Why can't we use tangent? We don't know delta x or delta y. Realistically, as soon as we figure out one of them, we could figure out the other one because of the Pythagorean theorem, but we can't use tangent straight away. That's why we have the other two trig functions, sine and cosine. All right, so this next page gets us thinking a little bit. In order to find out how high Juanisha climbed, we need to know more about the relationship between the ratios of the sides. So what strategies could we have used to figure out a side if we know the hypotenuse? We have some other special triangles we've seen before. All right, so we could use the Pythagorean theorem or triangle similarity, or another thing we could use is the whole 30, 60, 90 pattern. So 1 times the square root of 3, or 3 times the square root of 3, because these are both 30, 60, 90 triangles. They follow that pattern. Then if we look at the ratios, change in x over hypotenuse, we would get 1 over 2 and 3 over 6. Both of those are a half. So they should have the same ratios. Why would those ratios be equal? They're both 30, 60, 90 triangles. They're similar triangles. So all of these patterns are pointing to the fact that there's going to be new functions that relate hypotenuse to one of the sides. All right, so the triangle at the right, we should be able to figure out BC is 3.5. If you remember the 30, 60, 90 triangle, the short leg is half of the hypotenuse. The long leg, you would multiply by square root of 3. So if you do 3.5 times the square root of 3, you should get about 6.062. All right, now we're going to have nice direct ways to get exact answers. So we're going to have the sine ratio and we're going to have the cosine ratio. Now remember SOHCAHTOA, sine, if you're looking at one angle, relates the opposite side to the hypotenuse. Cosine, if you're looking at a specific angle, relates the adjacent side to the hypotenuse. So look at that picture. 60 degrees is where we're looking from. That would make the 1 the adjacent side and the square root of 3 the opposite side. So if you follow along with the fractions we're getting, sine of 60 means opposite over hypotenuse. That's why we would get the equation sine of 60 equals square root of 3, which is the opposite side, over 2, which is the hypotenuse. Cosine means adjacent over hypotenuse. That's why we get the equation cosine of 60 degrees equals 1, which is the adjacent side, over 2, which is the hypotenuse. So now we have tools for the whole way around the triangle. We have opposite to adjacent, opposite to hypotenuse, and adjacent to hypotenuse. That covers all our bases. So these examples, we're actually going to use trig ratios to write equations out. So we want to decide first, with the angle we're looking at, should we use sine or cosine? So this first one, the 23-degree angle, the A value is on the opposite side, and we know the hypotenuse. Since we have opposite and we have hypotenuse, that's sine's job. Sine of 23 degrees is going to equal opposite over hypotenuse, or A over 15. On your calculator, sine of 23 should get you 0.259. You know I like rounding to 3 decimals. Multiply both sides by 15, we get 3.885. For letter C, we have a cosine equation, because if we look from that 37-degree angle, we want to find B, that's the adjacent, and we know 8, which is the hypotenuse. Cosine is the one that relates adjacent to hypotenuse. So cosine of 37 equals adjacent over hypotenuse, b over 8. Use your calculator. Cosine of 37 is 0.799. Multiply both sides by 8, we get 6.392. So that's using sine and cosine. Next example, we're finally going to look at climbing this street. All right, so Juanisha's traveling 100 feet up the steep road, but we want to figure out how much straight upwards altitude she would have gained. Let's look at the information we have. So if we're looking from the 31.5 degree angle, we want to know how high she climbed. That's the change in y. So that would be her opposite side. And she knows the hypotenuse, the 100 feet. So that should be sine. We should be using sine for this problem. Sine of 31.5. You type that in on your calculator, you get 0.522. And then opposite over hypotenuse is y over 100. Then we're going to multiply both sides by 100. And so Juanisha would have climbed 52.2 feet when she walked 100 feet up this street. Okay, team tries again. So you're going to give these ones a go. So now you're looking for, should you use tangent? Should you use cosine? Should you use sine? Some of these you might be able to figure out with a shortcut. If there's an angle that just works out nicely, you can use a shortcut. So examples of those would be our 30, 60, 90 triangles and our 45, 45, 90 triangles. Everything else, I want you using sine, cosine, or tangent. Because even that table we used for our last note set, those were guesstimates. We want exact answers now. Not exact, but accurate 3 decimal place answers. Give those a try with your groups. Check your work in a second here. So there's all the work for the A through F team try problems. For A, you should have used cosine. For B, you should have used sine. C is a shortcut one, 45 degrees. You might have just been able to figure out X is 5 because it's a 45, 45, 90. D should have used tangent because it relates opposite to adjacent. E should have been sine. F should have been cosine. That's the entire lesson. Move on to your assigned practice. If you have any questions, make sure you save them for me for Friday. Hope everything went smooth and be nice to your sub, whoever you get. Thanks, everybody.